Let's jump to the hard page here on the first practice exam, page 3. This is the stuff we covered today in lecture on June 7th. So here we encounter problem number 9 here. With problem number 9, where we have to look very carefully, of course, on my exams I tend to put the important words in bold there. The ACS exam will not do that. But here we look and we see we have to organize these according to increasing basicity. And what that means here is that the greater than sign, this is the confusing thing, this greater than sign should be eating the, so to speak, as if this were a Pac-Man or some sort. It should be eating the strongest base. So here, whatever that strongest base is, we're going to have to list it in numbers. Let's find that strongest base in here. Let's see. This next concept that you have to know for problem number 9 is that since we only consider acids, the stronger base will have a conjugate acid that is weaker. You could say that backwards: the stronger the acid, the weaker the conjugate base. Or the weaker the acid, the stronger the conjugate base. So we look at these right here, and we're looking at a trend here. We're going to jump forward a little bit with the lecture. If I put an H on all of these right here, which one of these is going to be the strongest acid? Which one of these is going to be the weakest acid? Well, you can look at this in two different ways. One of them is seeing which acid is the strongest by seeing which one has the greatest dipole. Here we see on this one we have chlorines in addition to the oxygen, which they all have. The chlorines are going to take more electrons away from this hydrogen over here. So that would make that one the strongest acid right there. Or if we erase that, where's my eraser? If we erase that hydrogen and we have a negative charge right there, that negative charge is more stable on this oxygen because the chlorines are helping to stabilize it. So this is a weaker base. Remember, weak means stable. That's one thing to write down. Weak equals stable. Unstable means strong. Those are the terms to know. Okay, so this one is going to be the weakest base. That would go last in our list. That would be answer B right here. It's the only one where that one is the weakest. This would be the next weakest, and this one here is considered then the strongest of the bases. It is also the weakest acid. This one here, this hydrogen then, is the most stable. Okay, so B is on the answer on that one. On number 10 here, I'll stop actually on number 10 and let you guys do 11 and 12 on your own. But on number 10, this one is tricky. With both oxygen and the nitrogen here, both of these have two different protonation states. So let's take this alcohol over here. And let me show you this. I'm going to draw this in skeletal structure too. There's a fully protonated alcohol right there, where we can have a base come along and we can remove the hydrogen. I'm going to draw this without a base so there's no confusion. That hydrogen comes off and we form this. There is a pKa that is associated with that. This particular pKa is -2 from the pKa table. We could take another hydrogen off. So here we took one of these off. Here we're going to take another one off. And so we have 2 protons that are available to take off. Notice how this one here formed a negative charge that's unstable. This is going to be a lot harder to take off than the one that was over here. This one was very easy to take off, meaning it's very acidic. It wants to come off of the oxygen, so it's a very low number. Over here, this one's difficult, and that one's around 16, 15, 16 for those alcohols. That one's difficult to come off, and you can see the difference in the pKa's then. This is not very acidic, and this is very acidic over here. So the 2 different pKa's, you have to pick the right pK in this problem. The same thing occurs here with this nitrogen over here. Notice there are 2 hydrogens that can come off of that. One of them would make it negative. Go ahead and show that. So here, this one is fully protonated. To make that neutral, oops, we have to remove a hydrogen, and then that becomes neutral with a NH2 right there. That pK, it varies. This pK is roughly about 10 to 11. These are highly variable. We'll go over that more next semester. But the biggest thing here is to know if we take another hydrogen off of this right here and give that nitrogen a negative charge. Now it's negative with 2 lone pairs like that. That is highly unstable. So this one's not going to want to come off. We got a pK estimated at around 38 to 40. This is what I call the table 3 type bases. Again, 2 different pKa's associated with that. So when we go back to this problem and try to solve it here, let's look at first what it's asking. We have to put the strongest acid last in the row, meaning the greater than sign is going to be eating it. And in this case, our strongest acid would have the lower pKa. If you need to, you can put the pKa right above the problem here. This is his problem solving skills. This one's -2. This one here we said was 38 to 40, somewhere in there. This one here is about 16, and this one here is about 10 or 11, somewhere in there. So this needs to be arranged with the smaller pKa going last. That's the 4 right here. In other words, 2, 10, 11, 16, and 38. This is often the most difficult part, is arranging these according to order. If you do it like this and then put the numbers associated with it, you're less likely to mess up. So this one is 1, this one here is 2, and then this is 3. This is the last one. There we have it. That is our actual answer, which is C.